Yeah, welcome everyone. We're starting our workshop today, and yeah, this first part is about the project and theory and introduction. So my talk is about Chromatone. It's a visual music language that I'm developing for about 7 years already. And we're approaching this 3.0 version. So it's like a new stage. But it's not that it's something is changing right now because it's 3.0, but it's all the changes that accumulated through the 2.0 that I started last year. Because it was like I approached 2.0 with the whole bunch of ideas, but barely started, and it was just a big mess of ideas. But now those ideas have a shape, and pretty good shape. You know, it's much less bugs, and yeah. And I'm proud to present it to you, and maybe you will find it useful for yourself. So my name is Denis. I'm from Russia. But I live in Phuket, Thailand for 2 years already and plan to do this longer. So I'm engineer, designer, philosopher and artist. And I try to mix this, but not separate it in different parts of my life, but try to mix it in one coherent thing. And for me, the most coherent thing in engineering, designing and art is web development, open source web development, because I always feel connected to the community that's making all the packages in JavaScript and web development, and also all my things that I do, I can share the code, I can share the experience. We don't need a middleman in this. I can just give you a HTML file and you can open it and enjoy it. Yeah, I'm studying music and composing music for 10 plus years, and I started composing just as I started learning music, and I think composing is not a far thing. You can start doing this from scratch. And I'm developing this visual music system for 7 plus years, so after 3 years of drumming and trying to learn the solfege, it was problematic, and I designed the solution for it. And yeah, so yeah, I started as a drummer. Yeah. Oh yeah, great. But I think it's good. Yeah, and when I try to teach music, I try to start with rhythm, because yeah, notes are secondary. First is rhythm and patterns and repetition, and then you can just repeat anything, and it will be kind of music already. And yeah, it's good start, I think. Yeah. But then it can be tricky. Yeah, so here are my contacts. If you want, there is a QR code for the website that I have about my other work and CV and everything. But yeah, today we're talking about the Chromatone, and let's go like this. So what you can imagine if you think about visual music. It's colorful notes. It's my first idea. Okay, let's just paint those circles that are black and white. Let's make them red, green, and blue. Okay, but then geometrical rhythms. If we have a cycle of time, we can put some measures, some points on this circle, and those connecting points, we can get square rhythms, triangular rhythms, pentagonal rhythms. But next idea for me was that we can have audiovisual feedback. Like if you have a grid and you need to be precise, you just play your key at the precise moment and it shows you, are you on time, or you're a little late, or you're a little earlier, and you can adjust your timing just looking at this feedback system. So you don't need a strict teacher or very high level musician with you. You can just use some systems and apps, and that's big thing for me, that I really understood that if we have such a feedback system for yourself, you can just share it. For example, you play some note and everyone sees when it's played on the grid, and then they can share this point on the grid or avoid this point on the grid, so you can understand other people playing, and you can use visual ways to communicate. Even like when to clap, or what note we're modulating. So we're playing G major, okay, but let's play D minor after. How we will somehow dance it, but okay, you can say one something, but D major. Sometimes it's tricky, and if everyone's listening to you, you won't communicate openly, but you can just, I don't know, have a flashcard with the note and just say D major and something. So it's an explosion of ideas, and that's why I came to this idea. Let's put everything on one like research hub. So all the ideas should go in a tank, and then we will kind of develop them in open source. I would share them, someone will contribute to it, and that's my idea. That's how I came to this Chromatone.center. So it's like the website, and it's open source. It's called Digital Garden. So it's like pieces of knowledge that I put there, and they kind of grow by themselves. And it's a big thing already. So it started as just a place for my research, and this is the first part of it, so theory and all the music materials. So I go online and look for now what's the note, what's the chord, what's the interval, how are they related, how many are the chords there. I want to study that, and I go Wikipedia, just copy and paste it in a file, you know, and I think, okay, I'm clever now. But already I have it on my computer, I can open it and I'm bored, and you know, I'm still researching. And then when you try to put this knowledge into system, when you compare parts, when you analyze it, this knowledge kind of sips in your brain, and then it was useful for me, and I hope it can be useful for other people. But yeah, it takes some effort just to read and watch all the YouTube videos that are unrelated but somehow the same topic and all this. But after I was researching, I want to try many things, and at first I started trying with real things. So for example, when I was learning about intervals and ratios of the string, I used a real metal bar with a string from a piano that I put on it and fixed on two sides, and I have a block that I can move and divide the string in two, you know, and that's what Pythagoras was doing like back in the days. And I tried this experiment with a bow, so I listened to different frequencies, and it was so interesting to explore it by myself. But you know, even to build like 3 strings instrument, it's already kind of complex thing, and it was not easy. And then I thought maybe I can program it. Maybe it can be just more easy to make. Maybe I can explore it digitally. And yeah, some first apps became like this. I thought, okay, let's try it in web. And now I have more than 50 such experiments on the web. There is Academy that's if Chromatone.center is a place where I kind of accumulate universal knowledge that's like timeless, this is more bound to time. These are events, these are projects that are with some spaces, with some companies, with these are like all the things that happen, not persist, like notes and harmonies and rhythms. It's just this event will eventually be on the Academy website. That's all about. Yeah, just recently this summer I started personal tutorship sessions online, so you can just have a call for 1 hour with me, and we can just discuss any musical or music related topic from visual perspective, or any visual topic from musical perspective, education, professional stuff, anything. So it's like a flexible format. It doesn't bound you to some course. It's not only about education. Maybe it's about just finding your thing to explore yourself. But yeah, it's a thing now. And the stickers, I have some with me. Yeah, so you can then check it out. Oop, there was a plenty. I will show it on camera a little bit. Yeah, just to show. But I will show it now in more details. So theory part. It's 12 modules. It's how I understand the layers of music that we learn. It's more than 100 articles. More of them are like copy and paste still, but I try to not be. If I don't know a topic, I don't write about it. I need to explore it more. But when I know a topic, then I revisit the texts and I polish them and clean up and remove the duplication, and then it's kind of deep knowledge that's tightly packed. So it gets more and more packed with time. It's not that it's growing like a longer. It's not. It's more and more tight. And that's my focus because I want it to be easy to learn. Yeah, let's go dark mode. So this theory part is just sits right there in this corner. So if you go here, you come to this part and all the knowledge visible. Yeah, and we see that chromatone is Greek chroma, that means color basically, or skin, and tonos, Greek also word with like voice, accent, key, and a string. So basically it's colorful notes. So I suppose Pythagoras would understand what all this means. And I try to make it more understandable by people nowadays, and it's these modules. So these are really 12 of them, and it finally is synthesis and composition, but we start with simple things. So it's just color. And we dive in, and it's of course modules inside, like what is light, what is human perception of color, how we see the light and color, how we use it in mathematics, how we use mathematics to understand colors, how we call colors, yeah, and all these like videos there. And if we dive into light, there will be what is sun and how it works, what is like light spectrum that we receive from sun, and what is filtered with atmosphere and everything. So what is electromagnetic radiation? There are also these graphs, and you can kind of get to know the basic physics of it, because yeah, that's how I started, and that's what my engineering part is all about. So then we have sound, and I would say this is one of the foundational parts, because yeah, we need to connect sound and color, and I won't get deep into let's go a little deeper. Yeah, so if we want to connect color and sound, we need some rules, some function, some idea of which mathematics to use to connect them. And yeah, this is acoustic spectrum. So we have very different things, because sound is air oscillating, right? And light is electromagnetic fields. So they even don't interact with each other. They have completely different nature. And going through the sound module, you kind of wrap your head around how the air is moved, how our ears transcribe it into neural signals, and how our brain works. And then we know that infrasonic sounds are very low frequency oscillations. We don't hear them. We just maybe feel them like shaking things, and the table might shake and 1 hertz, like and then there's audible sound, ultrasound, hypersound, and basically heat. That's interesting, because if you oscillate very fast, it doesn't propagate, because it's just so fast that it's just hitting molecules. It's not that it's a wave, it's just molecules are randomly moving. And it's terahertz, but we need terahertz, because terahertz is in light, it's just infrared. We need higher frequencies to get to light. And this was my research. I just have this file, and I was calculating the frequencies, and if you calculate frequencies, you get to this 100 to 10,000 hertz, this audible sound, and it's like long radio frequencies. Doesn't make sense. If we compare to wavelengths, because air and electromagnetic field is different with waves, so a regular piano wave will be a length of around from 20 centimeters to a couple of meters, this wave going through air. And if we compare to electromagnetic, it's again AM, FM, microwave. It's not visible spectrum. So again, it doesn't work because visible spectrum is just only this tiny thing. Yeah, and the long radio, infrared and ultraviolet, X-ray, and gamma rays, basically. Yeah, so it's just highly ionizing radiation. But there is a simple thing that we know that a note like let me show. Yeah. So this. These two notes, they are like the same note. We perceive this and this are octave above. So we know that next note is double the frequency and it's like the same. If we start from C, next C will be again this kind of same note. So we know that we can multiply by 2 and go in these steps. And let's go in these steps and just imagine 40th octave of sound. So it won't be sound, it will be just imaginary number of terahertz, but we reach the terahertz range, and yeah, so 40th octave gives us 483 terahertz, and A comes to this spot with the red color. Really, it's just mathematically there, and you see that other notes kind of fit the spectrum. So it's you can see that B is not a little in place, maybe it should be compacted. And I was always thinking, if we kind of lower the A down, maybe we will fit the spectrum more easily. And this is one of these interactive tools that I have on the website. So we can just tune the A that's here, 4th octave. So this is 440, right? This is just normal A, but yeah, if we go for example 425, it fits a little better. So yeah, we can kind of estimate, but anyway, for me there's no direct connection, it's just mathematics, but it kind of fits, and it shows that our brain works in these cycles, because we think, okay, after red we have violet and then again red kind of thing, but it's not real, it's just darkness there. And with the higher frequencies it's also okay, yeah, it's somehow connected, but we have these cycles in our brain. And I thought, okay, let's use those two cycles, and we have spectral cycle of colors and chromatic cycle of notes. And that's how basically Chromatone appears, not as a arbitrary things, like if you go here you could read about synesthesia and some articles about it, but basically it's that some people really see colors, you know. Maybe you can find that you also have some kind of synesthesia, because it can be like this, you know. It's that you can maybe not only see colors, or see, for example, numbers like colors, with colors, like maybe 2 is a little green for you or something, but it can be like this, even like small numbers are to the left, bigger numbers are to the right, or letters can have colors for you, or words, or maybe some smell can have some shape, and this is just happens in the brain, and some people find it very uncomfortable, and it can be very painful and wrong to have this annoying sound happening if you see a violet color, for example, or have flashes of green when you hear D, you know. It can be uncomfortable, but it can be beneficial too. And there's a list of composers. So Franz Liszt has his blue colors in that he played, and Bernstein and Beach, and Scriabin is kind of famous for this. It's a Russian composer, and this is his colors, and but they were kind of arbitrary, and yeah, he was he had spiritual tonalities and earthy material, and it was kind of subjective. So okay, Scriabin, thanks for your ideas, but other guy will tell his different ideas, and then it's authority, and it's not an international system, but it was kind of big thing. And my idea is to go beyond this with more unified and standard approach because it can open new territories to explore. So yeah, then you can kind of see this circle in with more understanding how why B is yellow and why C is green. And but yeah, as I show this, funny thing is that you can really customize it. So my a friend of mine, he has synesthesia and his colors are different. And he showed me his keyboard. He just used some paper and printed the colors on the keyboard. And I said, okay, for you, I will do this. So you can just go and change the color. Yeah, completely to any of them. Yeah, so A sharp will be green, and it will be green throughout the interface. So it will be in. Yeah. So it's not colorful language already, because you can not particular colors. It's just universal, but if you want personal, okay, go personal. So it's not enforcing it. So I'm kind of proud for this inclusive approach. Yeah, but because you can even go and destroy the idea by making this like. You see, like a standard piano system. Okay, so A is white and A sharp is black again, and it's kind of boring. But yeah, you can make it black and white back. So it's welcoming for everyone. But we will stick to standard colors. Okay, I need to check on time. Yeah, to not waste too much, because it's long list, right? And you can see that if you want to learn something about notes, there will be articles within them, and yeah, you can explore these topics and go quite deep in them, because this is a big list of alternative notation systems, and I'm aware of hundreds of people who try to make new ways to show music, to describe music, like this chromatic stuff with a bit different distribution of notes on the staff. It was popular in late 19th century, or this dodeca system with their own keyboard, and this system that they used to with I believe it's fourth interval that they kind of mark there, and they have special system to how to write music. And but I understand that those attempts were not successful in a way that they can completely change the way people use classical notation system. It will be still there, and I'm not trying to replace it. I'm trying to make another gate to the same place. So finally, people just play music together. They don't read it, they just play and jam and enjoy. But how to get there? Some can go for music school, formal education, have like 5 years spent and big pain experienced, and or you can just go with colors, play with it, and maybe get in the same place or close to that space. Because my approach is not focused on just transcribing notes and making people play the notes and the songs. It's more about that you can be more creative, more free, and create things, not play from sheet, but maybe write sheets as you want. Yeah, but anyway, there is this scientific notation that I'm kind of using internally, but it's starting from C, that is 0, and then one by one the notes are growing in numbers. But yeah, basically what I use internally for sure is MIDI. MIDI is just, we have basically we have numbers for each note. And in all the computer systems, it's easy. One number and that's it. If you need to be in half between those notes, just put 0.5. It's decimals, yeah. So we have numbers for each frequency, basically. And we just need a formula. And I have this formula internally. So it's just every 30 degrees on this 360 degrees circle of colors, we have a note basically with steps of 30 degrees, and we can map MIDI to color easily, and that's what's happening there. Okay, we will just run through this structure and modules, because I have already a full-fledged course into music theory, but it's in Russian, and it's back in I left it back in Russia. Yeah, so my own course about this, like with proper video stuff and lessons, is still a thing to build and to record. But yeah, all the knowledge is already there, because I would go through rhythm and start with rhythm. Then it would be notes, and we will discuss frequencies and how we find which frequencies to play and which frequencies to avoid. But then it's intervals, so basically two frequencies together. Would you play an octave or closer with fifth interval and all? And I think intervals are the main building blocks for music, actually, because if you think in intervals, other things make sense automatically. Chords are 2 intervals or 3 intervals. Scales are 7 intervals together, but you can transpose. And I'm still not polished with this, not finished with this idea that you can reduce music to intervals. You know, I'm still going to chords and scales, because we need those layers of understanding to understand more complex topics. But in the end, I think intervals, you should try to boil down to intervals, because they are the atoms, I would say, of music. But anyway, after studying the atoms, we proceed to molecules that are triads, tetrads, so 3 intervals, 4 intervals, 7 intervals. And basically we get to scales. So with chords, yeah, it's interactive already. So major chord, we'll just show you what you have, what notes you have, how are they distributed, play them, and play for any tonic note. Yeah, so you can play it on your keyboard, on your synthesizer, or just here. Oh, I would say yeah, tune. Yeah, so just on your keyboard, on your computer. And this can teach you many things already. Yeah, especially this thing that shows you all the 3 frequencies, and you can see how they interact with each other. If you scroll, you will change the speed, and at different speed you will see a little different pictures of those oscillations. But I was mesmerized with this for a long time. That's why it's hard to write this code, because if you test it for then 1 hour just having fun with it. Yeah, but then you can just switch to minor and get the idea what's the difference between major and minor, right? So one small thing, and I would propose you to think about this circle in a special way. So imagine you're standing where the A is, and this circle is in front of you. So you can think about intervals like your 11 people around you, and so fifth will be opposite to you, but to the right, not opposite here, but to the right. And this is like your best friend. He's there because it's the fifth from you. It's if you play A and that's or here. They're very harmonic. They sound very nice together. And this is the guy across, but to the right. But to the left will be also a nice guy. But opposite to you will not be a friend, you know, and you should avoid this guy. But also there are guys to the sides here and to the sides there. And that's what I'm thinking about intervals, because yeah, so here are seconds and here are sevenths, and they are about dissonance, and they're harsh but interesting. And those are about emotion, because major and minor sit here, and sixth sit here. So you see, major and minor is just to the right here. I mean, you can use it because it's like what I'm doing is induced synesthesia. So maybe you don't have it in your brain, but you can kind of develop it in a comfortable way. And so, I mean, when you play, so you play this guy opposite to you, here. and you can choose major or minor here. So it's one way to think about it. But of course you can have it in front of you, but it's very useful to imagine it in your head. Because when I play ukulele with the stickers, I just realized that sometimes I close my eyes, but I still kind of have impressions of the colors that I play, because the stickers, if I look, I know that it will be yellow. But even not looking, I can think about yellow a little bit. And why is it useful? Yeah, why? Okay, one thing is to learn, but second thing is to have this thing always in your pocket, because it's just a website. You can open it anywhere. And then in a jam, someone shouts to you, let's play F Lydian, F sharp Lydian. And you're okay, but you never knew it. You never practiced it, because only in classic music practice, if you didn't practice E Lydian or F sharp Lydian, you're kind of broken, because you will have to calculate it somehow and get the idea. But here, okay, E or F sharp Lydian, okay, and you start playing. Yeah, and you play Lydian, and you play Lydian on your guitar or ukulele. Oh, so yeah. One moment. Do you have any questions by now? Maybe. No? Yeah, because it's kind of smooth. Yeah, this part is.
We need to spend some time on the website itself.
Sure. Yeah.
There is a lot.
Yeah, just.
But maybe one question about the format of
Yeah.
the website.
Yeah.
So we shouldn't follow it as a course, but rather pick a topic and then start from there. Or would you recommend going one by one?
Yeah. It's kind of linear thing. I mean, in terms of like layers of complexity. What I think that you probably can find yourself on which level you are, because with rhythms, after I was pretty good drummer, by then, but I didn't understand notes, completely. It was just too difficult to me. But after maybe 2 years, notes were already okay, but chords was still very, very shaky topic, and then you can just find this point, because what I learned is basically psychology. There is a thing that's called flow state. So it's happening when you are doing something difficult but manageable, that you kind of struggle a little bit but succeed. And
Because it entertains you.
yes, it's keeping the brain in this cycle of chemical cycle that's kind of like you have a will to do something, you want to learn something, you try it, you have pleasure, and it's a feedback loop that's going on and on. And for me, it's like this, and I go into topic. It's complex, but I find a way to make it less complex and study little by little. Then I want to do something about it. Then I see, okay, I really know it. Then I try to share it. And after that, I start new topic. But it's my cycle of learning. Maybe other people can have different cycles. And of course, I understand more people like to have a linear approach with a teacher who will just, okay, topic 1, lesson 1, how it's called, like part 1. Let's go next, second. And there's like a final result that you can be aware of. But I think in real life, you never know about result of what are you learning, because you don't know it yet. I was learning woodworking, thinking that it's my profession will be and I will love it. But at some point I understand, no, it's so much noise and dust, and it takes so much space, and I don't like it finally, And I still have all this woodworking equipment in my country house, but I realized that I don't want to make tables anymore. And I realized it after having all this. And maybe with music it's the same. Maybe, yeah, you can think, oh, I want to learn music to record my songs. But when you're learning it, you understand, I don't want to record them, I want to perform them, for example. And you don't want to sit in a studio, you want to play with a band, for example. Or maybe you will choose another instrument, or maybe you will become a composer or a dancer, I don't know. It can be different thing for you. It's just, I try to make it more free form for people. And what I'm coming right now is that probably I should focus not on teaching people music, but on teaching teachers of music to be more appealing and less, forceful, and not push people too much, but make them comfortable and develop in their own way. And there are many tools for this there. But also, if you can build your own way, yeah, and start from synthesis and not end with it. But yeah, the layers go like this. So yeah, because we have nodes, then groups of nodes, then groups of nodes, then again groups of nodes. So we need to call them differently and go step by step. So groups of nodes are scales. So these are some number of nodes, but we don't play them together. It will be horrible to play. So we have parts of it, and that's very interesting to explore. And what I learned in classical music tradition, education tradition, pentatonic notes are some funny little things to play, but I find it the most useful scales to learn and instantly start playing, because you cannot be mistaken with note. They all sound very nice together, and if you just play black keys, starting from some F sharp, you will get this sound, but it's very pleasant, easy, and you won't feel the harshness and problem, and you can just it's all good, and it's welcoming. And I think you can enter music with pentatonic scales, because we just play pentatonic, anyone can play any note, we will still have pleasure. Yeah, with other scales it doesn't work. But yeah, still, major pentatonic, minor pentatonic, suspended pentatonic, blues minor pentatonic. There are so many ways to get 5 notes that work together very, very well, or in an interesting way. And I think this is how we can grow, not by learning from Beethoven, Bach, and all these complexities, but still move in those steps, like one step at a time. Not that you need to dedicate yourself to think that you don't understand. No, you understand, you learn, you grasp. You understand, you learn, you grasp. So pentatonic scales are important, but then you can go deeper, and yeah, there's those monsters, Messiaen modes. Yeah, it's just crazy, harsh and dissonant scales, if you can even call them. But there was time. There was 19th century, beginning of 20th century. There was Malevich with the black square and deconstruction of music, and they kind of destroyed all this. Yeah, and in particular thing is that there is the big article about Indian music, Indian approach, and ragas, and they have different approach, but still they have 12 notes. They can still have colors, but you will call them sa re ga ma pa da ni, like this they always sing. And yes, and it's such a wonderful and interesting territory to explore, because it's pure math. Actually, it's just incredible math, because just imagine, there is how many? 72 of these ragas. Every one of them has a name. And knowing the name, you know these notes, the particular frequency. Because there's like separations of 6, 6, 6, 6, and there is a rule, a set of rules that you can know that sixth raga will be these notes, no, like lower, these choices. So these are choices of notes. Sa is always the same, but ri can be three variants, ga can be three variants, and which one to choose. And if you're good in with the ragas, someone says you, okay, tana rupi, okay, tana rupi. In your mind, you know there's a, and you see bigger letters. And bigger letters say no, not bigger letters. So first two syllables, tana, say that this is 6, because you know that, for example, ta is 2 and na is 3, because they know that every letter has a number inside. And after, from the name you extract the number, and from the number you extract the particular frequencies to play. It's just so fascinating. But yeah, it's like. I don't know. It can be overwhelming, of course. But for that, I of course made an app, so it will be easier. And yeah, it's all the theory goes here. But really, if you go to practice and go to scales, and then we have Indian ragas here, yeah, you will see these choices. So you can kind of flip these switches of different stages, and get here you will get all the lists of those ragas, and it's in more readable format, so all the spaces. And yeah, if you read this article and maybe browse this app and explore it more, you can maybe learn music as an Indian, as an Indian culture, not as a Western culture. And I think they're kind of equivalent, not that Western culture is superior. Mm-hmm.
Each raga have each time of performance.
Time, yes.
In the day. So in like in the morning, let's say you have to play this scale. In the afternoon, you have to play this scale.
Mm.
It's like be resonant with like
Yeah, but raga, if you go deeper, it's not like scale. Yeah, it's more than a scale, because it tells you how to move to particular notes. And yeah, so maybe in morning it will be more uplifting, like no, 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 and in the evening maybe like going down, and it's all codified there. But if you go to real Melakarta Raga teacher, he will be very strict to you also. I heard about it, and you approached it in the wrong way, and they have all this like strict tradition, but you can realize how to remember all these mathematics with just pure, without even writing it down, just telling it. So everyone must be very, very precise. But now we can have this app, and you can learn it, and you can just use it in your own way. You don't have this strict teacher. You can be mistaken, but maybe your mistakes, you like your mistakes, and maybe you can just be inspired by it, but not limited. So yeah, it's flexible. Yeah, we're still in the theory. It's already practiced, but yeah, we will finish the theory a little bit, because yeah, after scales we go to harmony. So it's another a little controversial topic. What is first, harmony or melody? Even with India, they don't have harmony at all. But basically, they have. So harmony is when we play different notes together at the same time, and not only notes, but maybe chords, and different instruments play different notes, and then they kind of interact with each other. But for example, in India, if there is like 3 singers, they will sing one note. They will not sing in harmony with each other. So it's kind of Western thing, but I understand that already, yes, in Western thing, harmony is basic, is foundational, because if we play just C major chord, you can invent melodies from it. You can invent many melodies. And from my personal experience, if I compose music, I would go for chord progression and then play melodies on top. And it's more approachable, and I think, yeah, if you have melodies in your head, like composers of the past, of course, yeah, you can go for melody. There's no limit. But my idea is to go from harmony with studying the relation between chords, between different intervals, how they work together. For example, how can you modulate from one tonality, from one scale to another, or how to use, how to basically how to play many notes together at the same time. This is the main topic. So okay, because before we studied scales, and now we go to how to use those 7 notes, but we cannot play them together at any place at any time, because if we go to a regular scale, like major scale, and play it, it's too much. It's too much. But we can play major, and the whole universe explodes from one scale if you know how to play harmony. And yeah, harmony is a complicated topic, but yeah, it's explored here with some articles, copy pasted mostly also, but yeah, there are clever people that write about it. And melody, yeah, melody is motifs, and one thing is that it's consisting of small atoms of melody, and it's called motifs. And you can be very creative if you understand how to work with melody. And yeah, this creativity goes to composition, and we start thinking about how to make a form, how to make a song finally, because yeah, people get stuck with the loop, having loop playing, and I like the melody, but how to stop playing this, I don't know. And yeah, composition is all about, so okay, make some rise the tension and drop the tension, make it strong, make it weak, and then you understand the thing that music is about relationship, and these intervals is like 2 notes, but you can combine, like use note and silence, or note and noise, for example, or loud and quiet, for example, and many ways to make music out of anything. And that's what I suppose is happening here, because guys here create such crazy music that cannot be described with scales, chords, intervals. It can be described with more complex ideas. But yeah, there is let's try to find no. Yes, notes. One moment. It's alternative. I don't remember where to find. Computer. No, it should be. Okay, I mean, there's weird ways to describe music, and you can create your own. That's the idea. Yeah, and this is last topic that's I'm studying right now, so it's very live. That's audio synthesis. So how do we make sounds with mathematics and gear? And yeah, it's very deep, and I suppose this for Synap Homelab, this is the most important part of the website is audio programming. So these are all languages that you can use to write your synthesis applications and sequencing and create music. Just so you can continue creating music just with computer and browser and not invest much in gear, because how it's called, gear acquisition syndrome follows you, and it's hard thing to overcome. Because for me it was maybe 5 years I was buying synthesizers until I understood that stop buying synthesizers, just use them. And yeah, that's where I am now. So yeah, with the synthesis, it's very complex, but it's even more beneficial because you understand the full path from just sine wave to the sound, and how all these ideas of filters and phase shifters and I don't know, pitch shifters and all this, how is it happening, what's happening there, and you can really understand. And it's just barely scratched, but this Carplus strong method is, you see, it's just very simple, and I already implemented, and I'm so proud that we already have these strings in the website working. Now you can just remember that a noise going to a delay. You can just, I will show you it in action. So yeah, this is the theory part. There are many some external resources that also explore sound and visual sounds and different parts of theory that I'm using, and this guy was very influential for my research, Willem Setaris, and we will proceed to his ideas in practice session. So if you have any questions about the theory part, ask them now, or we will go next. Mhm.
Maybe can you show the QR code again? So I guess
Yeah, okay. So this is the website, Chromatone.center, because the QR code is for my personal website. Yeah,
so you can go to Chromatone.center.
yeah, Chromatone.center. Mm-hmm.
So all the apps, all the web apps you should be running.
Yes, yeah. We will even have like some interactive, very fun thing to explore. So yeah, open it up. Yeah, and you can follow me if you want there. Yeah, great.
Any questions so far?
Yeah.
Yes.
Cool. So practice. That's already 50 plus apps. But as I said, at first they were very not good. They were just ideas barely put together. But it was last year, and this year I put to effort to polish it. And yeah, so these are apps now, not just ideas of apps. And yeah, they use web MIDI. Like MIDI through web MIDI, synthesis through different libraries, like I will show you later. There's audio analysis with very, very nice open source libraries that give me the data that I need and fast enough. And visualization, that's just Canvas, SVG, it's just web stuff happening in the browser. Yeah, and let's dive into it a little bit. Because, yeah, it has the same structure, kind of similar, maybe a little different in details, because I still don't have many apps for composition, for example. But for color, I have, and yeah, it's just can be as simple as just going and driving RGB values to get the color right. So we can calculate so this center piece is the color that we receive, and this is around. Have you heard about RGB and CMYK? Yeah, these color models. Yeah, so this additive model. So we, in this starting, we have just pure darkness, and then we start adding some color, some light, green light, and red light. We get this olive color, blue light. We get this dim gray, and we can just copy these values. It's just copied. You can paste it in your Photoshop anywhere. So it's just so it's a tool to learn, and I think that all these apps are made to just do this. You know, just look at this, and your brain will learn by itself. Your brain will learn. Okay, green. I add green. I remove green, and this is the color that I get. So if you see purple, you will say, "Oh, purple. I remember. Purple is when there's no green. There's no green, and that's purple. Okay, great." Or you say, "Okay." You will say, oh yeah, there's green with some blue. So you can have this notion not from study, but from just pure practice. And yeah, if you're into print, you will go for CMYK. So you have white paper, and you have four of these colors, and you add magenta, add yellow, add cyan, and you can add black, because in real life, if you mix those three, they kind of get black in digital, but in real life it will be not too dark, and you spend so much money on three colors filling to get black, so we have black separately. And yeah, you can still have this calculated, copy the value, and yeah, it's the same. But this is already kind of esoteric because if you could learn about it, so if you go through theory, you will know about these other color systems that are more consistent. Because yeah, if you see HSL that is used in Chromatone, actually, you will see that yellow is much brighter than blue. Its brightness is different, so it's kind of not equivalent. But there are more precise and equivalent models. So LCH allows you to have the same brightness of yellow and blue at the same level of L lightness. But yeah, it's very robust. You can just play on your telephone screen, because yeah, it will go with touch. It has this spring effect, so you can maybe throw a random color like this and just find it very useful. Yeah, you scroll up and down for saturation, and yeah, I think that, I don't know, interior designers, maybe graphic designers can find this tool very useful. And you kind of feel the notion. So it's kind of useful, educative, but in a way it's kind of fun and just explorative. Again, this is a lab color space, and this is pure math. This is very, very foundational, so it's not my ideas, it's not a toy. It's really an instrument to just precisely find the color that you want. So I will finish with this. So it's a palette generator, and yeah, you can have one color here. You can drag around this hue, saturation, and lightness, and you will get the name of the color, and this hex value, and the final color kind of thing. So let's go to this purple, and also you can drag around and have more steps. I find it kind of useful to many things in graphic design and everything, because yeah, you can just download the SVG file with it, copy and paste, Illustrator, yeah, and go where you want. Yeah, so I try to make it more useful, and you can export things. Not only this, I will show you how we export MIDI files and everything. MIDI color mixing, and this is just a thing that we made for exploration, and let's add some colors and notes to our thing, because yeah, it's practice. So we can, if you play any notes on your keyboard or your MIDI keyboard, then it will show you the colors of those notes and the mix of those colors. So this is mathematically mixed, those three colors, and you can think about the colors of chords, but it was used in a neurological research. So they were having these electrodes connected to the skull, and people were looking at this, and we were kind of taking the encephalogram, you know, this signal, and trying to find something, but we need more research on that. It just barely scratched the surface. Yeah, that's color, and yeah, you can imagine what's happening in the sound, rhythm, and everything. It's kind of exciting, yeah. And we will go, I think, like this. I will show you some of the most interesting parts, just to have the idea. You can maybe browse and find something while we will be going, but we will not go too deep. This will be like the workshop part, where we will just explore precisely what you're interested in. So just try to catch your interest where it fits you. Because now I will describe my process of developing it, because there are some foundational things that, as I said, I started with just a metal real string and real things to explore. But then, okay, I had all the tools. I was welding. I knew how to do it. I had this piano string, and I have the bow. I spent money on it and time, but not everyone would be comfortable with this. And that's why I just built this app as one of the first apps that I built. But recently I just fully rewrote it, and it's using this synthesis and everything. It's kind of good. Be careful, it may be loud now. Kind of fine, okay? But the thing that I have experience with such a string and bowing, I would say this is the sound. This is a harsh, a little dirty sound coming from this delay line and just the noise coming in. But this is how the string sounds. Yeah, it will be loud, but this app is just... I will adjust this because it's... yeah, I will show you one graph before. Why this? Do you know why this E? Okay. No. Why is it louder? Because this second one is obviously louder, but in all this synthesis, it's not louder. It's the same volume. Okay.
Because human perceive higher pitch louder.
Yes, exactly.
Not that it's
Logarithmically, and also it's even not up to logarithm, yeah, because there is a thing that you can read about it in this theory section, but what we have here, again, beware the loudness. this is the sensitivity curve of human ear, like average human, and this is so this is the line of volume that is perceived as equal volume. So basically 200 hertz. I will need to go higher, but just shift the curve. So this 233 hertz something, so it's very fluent, is on one level of loudness. But if I go here, this bass is kind of okay, maybe same volume, okay, but this we don't hear it. Where's this red? Oh, it's too low. But if we go, so oh, it's all the way up here. So to play a note, and there's the color. So okay, I will find some same color. So you can see that you need to play lower volume of this note, and you can go and find more. And you can draw your graph, so you can explore your own curve of your sensitivity of your ears and compare to this average. And yeah, this is the tool that I think very powerful, but also very complex at the first. But when you understand, you can be very precise and find this even this sensitivity. This is basically peaks of sensitivity, and humans have peaks on and main peak is around 2000 hertz. It's voice range, and there is like high voice range. We are very sensitive to high, like women or children voices. They seem louder actually. Like a child crying is the same as an adult crying, but because we're more sensitive, we will say, oh, he's crying much louder than this.
They also say cats imitate babies, so when we pay attention to cats,
Yeah.
imitating
Yes.
human babies.
They're hitting this sweet spot of our sensitivity. Yeah. Sure.
And I think it's gonna be fun if I try to doing my synthesis, but according to this graph to be a bit more like mellow.
Yeah.
From like because sometimes when I do like 10,000, it's so loud.
Mm-hmm.
Because you can like multiply by one. Right?
Yes. Yes.
So you can clearly see like okay, this is like high pitch is like so loud, and like low pitch is like so.
Yeah. You can. I think you can estimate this curve with some simple mathematical equation, maybe hyperbola or something, and just put it in your pure data, so it will be more consistent with ears. Yeah.
Like lookup table with it.
Or yeah, lookup table. Yeah, it could be easy with some interpolation. Yeah, so this is very fluent, and you know what fascinates me, that you already have this range of every possible frequency on every possible volume level, you know, so you can just train your speakers or find the resonance in the room, you know, you have it in your browser, you can just, okay, this is fine, but what about 20 hertz or like 17 hertz? It's just, oh my god, it's so fascinating. Or like, no one will hear this, right? No one but this. Yeah. But cats already. And no idea. And dogs. But okay, let's check it out. Everyone, let's raise your hand and put it down when you stop hearing the sound. Okay. You don't hear it? Okay. You don't hear it? Okay. Still? Oh man.
Yeah, still.
Still, wow. No. Wow, you're kind of youngest ears here. It's around 16,000 hertz. It's very, because they have this like age of ears. Yeah, so I already.
It just got my ear treated, so like it's come back a bit.
Yeah. So yeah, it's good to have it. But yeah, it will wear out anyway. But it's.
My high level, what I can hear, you can repeat this?
Sure. We will go with the other tool and be more precise, and I will show you, because yeah, it's a sound, but we can move a little further. Yeah, there's a pitch table for this. And I will show you another fascinating topic along with it. So pitch table is a table of all possible pitches. And you can just click this square and it starts playing this sine note. We can play two notes, or better, I would choose major. So we have more pleasant thing. So you can adjust level and left to right. So it's a bit buggy, but it's one of the oldest apps here. But it kind of drives me a little crazy. Yeah, so let's go higher. Let's go B4. Easy to hear. You still hear it, right? This, okay. Still, right? It's kind of still in piano range, maybe a little over piano range, but this. Oh, so yes. All right. No. Okay. Let's go. No. Okay. Ah. Yes. Ah. All right. Mm-hmm. Oh, sorry. Oh no. It's just wrong click. This one. Fading out, right? Because this. For you, it's just the whole octave for you, yeah. You hear it? No, this is so around 7.5 kilohertz. 7.5 kilohertz. A sharp 7. But it's quite good. I mean, it's beyond piano range. It's beyond musical frequencies. But it limits your because high frequencies are important for harmony. So maybe you can miss some harmonies because you don't hear some of the interactions of higher harmonics. But it's not a big deal. You can use colors and you can analyze and you can see music, you know, if the one that you don't hear. Yeah, so this is maximum. Okay, let's try your limit because it was already 16. No. Okay, next. I'm going down. Not yet. Ah. Oh yeah, yes. Up. Hear this. All right. Almost 12 kilohertz. So yeah, 5,000 hertz. You have more.
I normally like do like 10,000 hertz in my like.
Oh yeah.
Yeah, like 10,000 hertz.
10,000 hertz.
It's like easy to time down like 10,000.
Ah, yeah. Maybe your ear is more linear with this, or exponential. Yeah, but okay, we went up. We've heard all the higher notes, but let's go down. You know what happens there? I was kind of.
How subwoofer do?
Yes, yeah. We will check it out. So it's okay. 200, around 100, no problem. Let's go C. So 65 hertz already, and imagine the length of this note is already 5 meters, and that's one thing that I'm using this table is to find the note of the room, because the length of the room and the length of the note, if they are the same, you get crazy resonance. And I won't practice it on this volume level because it can be really destructful, yeah. And should be careful with resonances anyway, yeah. But I know that my room is F sharp, you know, for sure, and I have to cut it if I want to listen to it. And
This is also a case when I do sound in the top as well.
yes.
The kick drum in the top is like the different. Before we do a show, we have to tune this
Mm-hmm.
to not like keep on one.
Yes. Yeah.
We have a bit of issue when the bass kick drum like resonant through that building.
Sure.
Because there's someone like sleeping.
Yeah, and you can estimate it. I mean, now it's a simple formula to convert frequency to length, to meters, and you can estimate this frequency by knowing the size of the room. If you know the size of the room, I can estimate your resonant frequency, you know. I would estimate it's like maybe 6 meters or 6? 8. 6, and this is around like 4. So 4 meters is around here. But the speakers are going there, so let's go longer. Okay, we're going longer. We're going about this 7. Oh, that's closer. It's we can because it depends precisely. So now I'm triggering notes. Maybe it's somewhere in between. Yeah, but you know the tools where to go. So, but we will go down, go deeper. Don't be afraid of because of your subwoofer. We have it's a sawtooth wave. So it's just moving your subwoofer like ting ting ting, and let's listen to it. So this is a note. This is a proper bass note, but this it's like engine. Yes, it's 17 kind of thing. Yeah, you know this still, yeah, because you just type it, right? But
Yeah, so when it's like slow enough, it becomes like
clicks, right? Yeah, it just clicks, and it's just diaphragm moving. So if it would be like sine wave, we won't hear it because it will be moving like very slow, and we could look at this and it would just be moving in front of us, but it's moving fast and then slow, fast and slow, and we start hearing it as like so it's like an engine working, it's a motor. It's not musical, it's not a note already for us, and it's something in between, and that's why it's like in dark black. So it's transitioning point, but transitioning between what? And it's very interesting because this is just rhythm. You can guess maybe the BPM, right? But it's 520 BPM. But it's already BPM. Yeah, let's go deeper, down. And I will choose C major because it's kind of fascinating that C is it's 4 hertz, and it's just 1, 2, 3, 4. Yeah, it's just rhythm, and its note is rhythm. Rhythm has notes, you know. It's so great. It's not geometrical rhythms. It's just notes, and rhythms are basically the same thing. And yeah, going down, you can house music. Come on, yeah, 120 BPM, yeah. So it's C minus 5 octave. So from my understanding, it's not only C, but it's green, you know. So this is green tempo, and yeah, green techno, yeah. Because if you go for like drum and bass, it will be faster. And just let's put them together. We play fifth. 2 to 3, right? It's 2 to 3. So one plays 1 2 1 1 2 1 2, and next 1 2 3 4 1. Oh, 1 2 3 1 2 3 1 2 3 1 2, and together is. Okay, I will play it by myself. Look. So 2 in one hand, 3 in another hand, and yeah, this is how it works. So you can explore polyrhythms with notes, and it's kind of mind-blowing. And okay, this sounds beautiful, but we know if we play, so it's the same as playing playing these. Harmony, beautiful, fifth, 3 to 2, and again it's here. So this is equivalent. So it's now it's intervals of rhythm. So polyrhythms are intervals in rhythm, and yeah, what if we know if we play something like this? it's harsh, it's interacting in a not beautiful way. But what will be in the sound? Do you know what will happen?
Like very odd ratio.
Yeah. So we get the beating. They synchronize and go out of sync. And they back synchronize and go out of sync. And we get this beating. And this same beating is what we feel not good about in notes. But in rhythms, it can be interesting. But the cycles are longer. And this longer cycle, the more complex is the pattern, and then you need more brain power to process it. So maybe you can enjoy it, but new people to music may be alienated. But yeah, so we end up in this 1 hertz. It's very slow, and I know that somewhere after this, less than 1 hertz, beats become unrelated. We don't feel that they are connected. It's just 1 and then again 1. It's not 2 already. And after around this A-6, we don't have another modality to perceive. It's just random sounds for us. So this is the whole range, from not meaningful clicks to very, very high-pitched mosquito sounds. And it's only this in this table, you know. It's so useful, and I enjoy building it and making it open source and useful for everyone. Yeah, so I showed you this monochord because I need to control time. Oh, you. Okay, I will show you this because it's kind of foundational. Then we will start more workshop part. We will be more explorational. But this tool is very nice because it's where it all started for me. So I will refresh again. Sometimes it needs some refresh. So A, and then we have this slider. And we know that good ratios of 3:2 or something sound good together. So okay, put 3:2. Nice interval. Again, we're more sensitive, but quite nice interval. And yeah, if we move around, we see, oh, this is close, but already not even. And we can just slowly slide around and find good sounding, bad sounding intervals. And this is the list of the most useful ones. But maybe you can find something by yourself. That's why it's very fluent. You can use your touch, you scroll and find and be creative. But yeah, this is like I'm giving this metal monochord in your hands, and yeah, it sounds very real, and you can explore it. Yeah, so ratios, intervals, sound, we kind of covered. String overtones is one of the most important parts. Do you know about string overtones? Never heard? Okay, I will show you. Yeah, so we are kind of floating in the space because we don't have foundational theory, but I will try to mimic it with one picture. One moment. Oh, no, I will show it everything. It's fine because yeah, there's the violin, and this is the string oscillating, and just try to notice that it's not oscillating like one vibration of the whole string. It's a sharp corner going in a circle. You see, it's going far and coming back, and it's like angle, like a corner, and it's called Helmholtz angle. It has its own name. So if you pluck a string, it will first move in this sharp shape, and then it kind of makes more and more smooth and dies out. And mathematically, it means a lot, and I will show you it here, and probably it will make sense. I suppose it would make sense. So we start with just two modes. So one thing is the string can move in this direction, like the whole body of the string can move like half a wave. But another thing, it can move, you see the second, it's not moving in the center, but oscillating two parts. And you have in the center. Maybe you can have a string to demonstrate if you have, yeah, because it means that you can have a sound octave above the main note of the string, and if you just put your finger in the center of a string and pluck it, it will be double the frequency of the whole string. So it's and you see the mathematical sum of them is just already similar to that angle. You see, it's kind of moving. Now it's on the left. Now it kind of bounced to the right, and it's just sum of those two. It's just mathematics. I promise you, I put math and I look at this and wow, that's fascinating. But then, okay, we add third. So there are other points, and they are shown on guitar. The lines show where to put on guitar, and you can place your finger and still pluck it, and you will hear the sound that is third, that is higher, and it's fifth above. Yeah. Okay. So, like this string. And on something. Where's So there are points, if you scrub around the string, there are points where it's not sounding, but there is like a note again. And oh yeah, I found it. Yeah, on guitar it's much easier because it's here. Yeah. No.
Oh, yeah.
So half of a string sounds an octave higher, but you can put your finger in the third point, and why is it happening? Because you place the finger here, you cancel out, this cannot appear, this cannot move, it's fixed there, but this can move, this cannot move here because you kill it with touching there, so you kind of select which frequencies, which oscillations you allow and which are not allowed. And this is very interesting. You can just scrub around this string, but you can scrub around this app too. Because yeah, if we add more such frequencies, more such harmonics, we estimate. We estimate that shape that we've seen in real life more and more precisely. And that's how we understand that. Yeah, so that shape and that sound is a sum of other pure sounds that just combine in this timbre, this interesting sound that we perceive from a string. And just try to remember this distribution. I would just lower it down for 7. And just see, so we have like the note, then we have fifth. But yeah, we have first, okay. So we have the note, then octave above it, then we have fifth. So for green we have purple, but we can estimate other colors, and of course you can choose. So for purple it will be mint color, for yellow it will be violet. So you always know it's fifth. It's this kind of opposite color. Then again it's repeating, and then it's so they have mathematical ratio, and now I think it's time to go to this most interesting and most useful part. But I know how we will go. You understand that this is huge, and this is very important, and we will go for this workshop, but I will just rush through other parts and just to sum this up, and we will not need to come back to other parts of the system, and we will go to practice completely, because there is something more than just apps and code. There is people learning, and that I meet across my in my journey. There is all the materials, the events that we make around, all the projects, collaborations happening, and I try to put it all a little aside from the main project because it will be overwhelming and too much. But yeah, it is Chromatone Academy. I thought it will be bigger by now, but I was on the brink of burnout. You know, building it's hard. It's a big thing to make a coherent academy by my own. But yeah, that's my knowledge and my experience packed into this website. There are public talks, and I believe this talk is already here. So here is Synap Homelab today. This is my yesterday talk, and there are other talks that I gave across the years, and this one the last year that I talked in Bangkok also. There's good recording, and that's around where it was only starting back in the days in Moscow. And I think this was my first public speech about the system. So after 2 years of development, I thought, oh, I'm doing it so long, but now it's 7 years and it's only starting. But yeah, so imagine there's like talks, stickers. This is my idea about how to make like music documentation. I have this long-lasting idea because there are frameworks how to make documentation for software. And why don't we make documentation to music itself? You know, it can be done, but it's a thing to explore. This is like the course that I built in Russia, and so there are 4 ways that it all grows. One is the theory part, okay. Second thing is to jam and how to jam. And here are some jam events. And this one was 1 year of every week events back in Phuket. Yeah, so I tried to record most of them and make streams and explore things. It was a little grassroots, and we were just starting, but yeah, there are some experiments and all the polishing when you start with the app and there's bugs in there, and in public talks you cannot fix it. But on the meetups, I could fix some bugs and find them. And we got this structure of talk, jam, create. 1 hour talk, 1 hour jam, 1 hour like recording and performance and doing some, to have some tangible result. And it was nice. And I keep the record here. So maybe we will have some record more with our collaborative projects and all. There is live multimedia production is how I make music with my synthesizers, and how to make a portable setup, because I have my music published, and there's the lightsaber that we're building. So all things that are about gear, basically. So gear is here, and my Unity project is there. With the I will try to use it maybe today in the performance. And development. So how I build it with HTML, JavaScript, CSS, and graphics. And all of these will eventually evolve into courses and studying groups and maybe some feedback groups, but it's not there yet. I hope to make it more in future. But still, it's storing all these interesting parts. Shop has its online shop has stickers, memos, and some printable designs. So yeah, it's another website. You can just have a browse it, find stickers that fit your instrument, because there's stickers for guitar, for ukulele, of both of them, and these are abstract stickers and also useful printable things. Printables are here, so you can print it yourself. Just download the PDF. And that's the only thing that has a price tag in the whole system. Oh, it was, because now there's another thing. I forgot to put it here. Okay, there is tutorship. I forgot to put it here. It's fine. So yeah. There's tutorship. I was already mentioning it. So yeah, it also has a price tag, but yeah, I tried to make it approachable. I won't get deep into how it's built. It's just because it's all open source, and I. Yeah, sure. There's GitHub. Yeah, but it will open just in a repository. Yeah, because if the Wi-Fi is good, is fast enough, it will load. But here it is completely. In the entirety, you know. So there are folders for components that are all interactive parts, the content for the texts, and all the texts are here. If you go to theory, chords, and clusters, you get the text. So everyone can edit it, and it's open source. So I was waiting for people to join in and start developing it. Now I'm not waiting because I understand people just hard to motivate to do something on open source. But anyway, I do it still like open source because I know that I grab open source things and I don't write to the authors thank you. I just grab it and use it, but I feel gratitude, and that's why I do open source, because I feel real gratitude for all of them who who invest their time into open source. And so yeah, there is a usable components, usable JavaScript elements that you can just import in your JavaScript project and start using it. And there's a theme, there is a database that can be also quite useful for developers, because it has, for example, it has all those Ragas.
Wow.
Yeah, in YAML format, so you can read it by your eyes, or you can maybe explore it in many ways with all the names and or just scales, or crazy big list of all possible scales in the world, you know, and because it's a limited thing and it's only 4,096 available scale variants of combinations of 12 notes. And they apparently they have names, all of them. Someone named.
So you got like two note scale, 3 note scale.
Yes, until 11 note scales and all the types of them.
Still like in the chromatic.
Yes, still chromatic. Yes, still chromatic. So yeah, it's very useful. You can make, I don't know, like a game, guess a scale or anything with it. And I grabbed it somewhere. I tried to make it consistent with the format, so it's YAML format. For example, rhythms.
Chroma in the chroma is that note on or off, right?
Yes. Yeah, it's you can see it even with like scales. Yeah, chroma. Yes, it starts with 1 always, because it's one first note is 1, and then
Rotate it in any way.
Yes, rotate it and get it anywhere. Yeah, it's here. You can see it here, because there is one. I put one note that is thicker than another. You can, if you put A, you see it's just a little thicker than this. Yeah, the root, and yeah, you can just rotate it. Yeah, so it's the same minor but rotate it, and you get this pattern. Yeah, I enjoy it. It's quite consistent and easy to think about it. But looking at this, you don't realize what's happening there. So numbers are not enough. But with colors, it immediately gets meaningful. So there are chords, color lists, you know, rel colors, many bits of knowledge, like rudiments for drummers who practice drumming. They have drum rudiments, and they are here in the shape of like some YAML that I derived from MIDI files that are going around on the internet. But now you can go to rhythm and have these drum rudiments. Look at here. So or you can look at them. Yeah. So they are not playing now. There's no interactivity, but at least I visualize them. So you can think about them is a visual thing. Some of them look a little off, but it's just converted MIDI files. So maybe they have some mistakes. I'm not that precise about it, but yeah, anyway, it's 9-stroke roll and everything, just left hand, right hand, quite simple. For example, this single stroke 4, yes, left, right, left. So you can, if you know, you can for example, watch a video, but with this you can just memorize it easily. So all this data is used on website. It's just not laying around, but I suppose other people can use it and it can be nice for them. Yeah, so this is still not loaded. Yeah, so it's available on NPM packages, so you can just use it in JavaScript project. Yeah, it's a bit messy, no documentation still, so it will be interesting to find people to invest their time into documenting it. But yeah, let's go to more interactive approach. But before, any questions about this structure and project, and how is it growing, and maybe your ideas where it can go? No? It's okay. Yeah, it's okay. So we rushed through this because now we have an hour to get more into details in this exploratory format, and I would ask you about your feeling, how you feel about like this knowledge that we explored now. You can show me or 5 fingers. Just if one is you don't understand nothing, and 5 you understand everything, and it's easy to go for you. Okay, just show me, please. 2, 3. 3, 4. Okay. If you don't understand anything, show 1 finger. And if you understand everything that's happening, I mean in theory and practice by now, you show 5. 4, 3, 2, 3, 2, 3, 3, 3, 2, 3, 4. Okay, okay. So we're not lost. That's what I wanted to check. And you. Oh, great. 2, 3, 4. Perfect. Let's go deeper. That's what I was, because I was going here, and you know, guys on this screen and these speakers, they play crazy sounds. I don't play them. I play pretty consistent, like bass, kick, you know, chords, but they clicks, swooshes, and all this. And I was thinking, how do they look? Can we see them? So. Because we were now speaking about like theory of music that we can play. Okay, we can put colors on stickers and play colors. But can we see the colors that are already there? Can we analyze music? And it makes total sense that yes, we can. So we can just have our microphone. I need multiple. Allow multiple things. So now it's getting fun. So this thing is analyzing sound that's coming to the microphone in my computer. You can run it also on your device, on your phone, iPhone, iPad, any device, and it will analyze incoming sound. And we have the formula for colors of sounds. So they have colors. It's a little messy because we have noise from street. But we can still manage it because there is mathematics. We can shift the midpoint and cut off the noise. Oh. Okay, there's still a little A noise, but you see my voice is there, so it's live, it's real time. And also we can increase and decrease contrast. So higher contrast will show us precise colors, but lower contrast will give us more details about like small things. But now, remembering this colors of a string and these frequencies above, these harmonics of a string, maybe that my voice doesn't make 1 line, but multiple lines will make sense for you. So, oh, let's play this. Maybe. Oh, let's try. Here. And another. So let's look at this. Can you guess what notes did I play? C. It should be green, right? But you can guess because you probably know what open strings on violin are tuned to. So it's C. Out of tune. That's why. Because it should be green, but it's a bit yellow. But you see, yeah. But I mean, we can have a discussion like people with absolute, with the perfect pitch. we are talking about music like we have, but we're just looking on the screen because we can see music by now, and we can see, and I'm sure, yeah, it's C because I've this is violet, so it's G above, and it should be C down there because for B it will be like G sharp. It's I mean a different color, right? It's just okay. It's okay. This is G, and G sharp is almost like red. So if I feel it has blue in it, then it's going kind of C. So you get this grasp because the string vibrates, and all these modes are here because this is spectrogram. It's showing us the frequencies of sound, and one string vibrating has multiple frequencies, and also these overtones. So okay, here. One moment. So again, we have, this is main tonic note. This is octave above the same note, and this is fifth. These are our main harmonics. And one thing that higher harmonics die off earlier. You can see this shape, and you can think about it in synthesis, right? With the filters going down, and yeah, it's natural. And then if we play this, and then yeah, it's literally isolating this harmonic. So you see when I play when I play this full string, and this is half string, and even if I barely see this, I know that there is third. And there we cannot, it's not available because we cancel it out. And you can have all these ideas just from looking at this, you know. And there are many insights just waiting there. Like, you know, I was experimenting this ma, 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 ma. And so there's 5 tones, right? Middle, low, high, not rising, but like ek to tri chat ek to tri chatawa saman ek to tri chatawa chai. So 3 tones, you can just look at them and practice and maybe verify if you're correct without a teacher. Sure. Mm-hmm. Yes. Egg. Yes. Do. No. To. It should be to. It's up and rapid up and slower down. Cow. And then cow, and then cow. It's chatawa. But yeah, I mean, we can go even more precise if we speed it up, and then the cow, and yeah, you can see precise movements of your pitch. And there are some adjustments you can do to the smoothness of this and to frame sample rate, and it will appear like this. More smooth, but it can be easier for eyes and maybe easier for singers to sing along, and maybe maybe it can be fun.
This is like partly like
Tuner, exactly. Yes.
We show tuner.
Yeah, tuner. Yeah, you can just, and it's good because yeah, you can. You can find it, you know. You can look around for frequencies. Yeah, and it's very nice to have such tools. But of course, yeah, it can be easier to just have a tuner. it's a bit shaky. Yeah, it has one is for the note and another is for distance, because like cents, you know, like basically percents of not fitting the same note. So, but I'm still struggling with maths for smoothing this out, because it's just random. It just picks up some noise, and if we plot this graph, it looks like this. So it's kind of guessing, like but it can be shaky at some point. And yeah, you see these random points, and if I need to filter them somehow, because they make it all jump around. Because now you can see I'm still having this. My basic pitch is around D, C, something like this, and I know it, and I can know that I can sing in C or D more comfortably than in G or F, you know. So like even going for like your vocal range, we can just even practice it together a little bit as a part of our workshop. Let's do it. So I will do myself, then you can do it too. So, but filter it a little bit, make it cleaner. Oh, that's mine. So it's around G, yeah, and lowest is around B. So, anyone wants to try? Come on, don't be shy. It's easy. Come on, come on. You? Come on, guys. Yeah, come on. Yeah, you can go from highest. You can go. It's a format. Try to go higher.
So I think this is clearly show that when you have one tone,
Mm-hmm.
it doesn't a case that you have the same like harmonies.
Yes, you're shaping.
You're like the sound.
Yes.
Your mouth to have like different kind of harmonies.
Right. Yeah. It's called formants, you know, and it's timbre. So you control it, and even looking at this, I realized that I can probably we can probably recognize formants, because like again, one moment. So yeah, A is kind of default, but E is even brighter. But you can see that for E we cut the higher part. For O we cut the higher part even more, because this is O, this is U, and E is when we have low part and some high part. This is E, and looking at this, I understand that maybe some even deaf people can not only understand music and sound, but even can maybe understand the meaning. Because, okay, let's say, hello. So it has this particular shape, and you can know, like, there's o. Like, you can maybe, if we make it more precise, maybe some precise tuning of this sensitivity, maybe it can show some patterns that people can recognize. Because if you think about it, neural networks recognize this. They use spectrogram as their input, and that's how they
transform spectrogram into visual data into pixel.
yeah.
Use pixel to like do like the neural net kind of thing.
Yes, yeah, exactly. So this is how neural nets understand music, and maybe will help us understand music too. And it's obviously helping because yeah, okay. Now we can switch to this input and go to pitch spectrogram right here, and it's not showing anything, but I hope it will be working. Yeah, so it's coming from my synthesizer right now, so we can see and hear the pure sound without the noise, and this makes us oh yeah, a little higher. Yeah. So, for example, you can make have understanding about the filters. Yeah, let's have a brighter sound. Yeah, I have bright. It's brick. I don't know. Some noise suppression happening. Yeah, this bright sound. We can say with vibrato. Yeah, we can just see vibrato. We can see this bright, and it's like filter is kicking in, right? It's just cutting frequencies. But if we open the frequencies, that's where it happens. We see more frequencies. And then we cut. It's high pass, so we cut the lower frequencies. Or we can isolate the lower one. And then even with the okay, I don't know why is it happening, but we will just continue. So we can look at filter and resonance. Very interesting. So many insights, so many things to think about. Even how it kind of breaks through the note, and where filter with resonance can create new notes, new frequencies and sound. Like if we still hold on this. This is. Very narrow moment where we have resonance doing very weird stuff, and I think with live coding you can explore this territory and yeah, make maybe some sound that is very unusual and new. Yeah, and it can help you recognize, yeah, so kick drum and even patterns of kick drum. Okay. I will refresh.
So as we can see, like more the percussive side of the sound.
Yeah.
Containing all.
Yes, containing all frequencies. Yeah, yeah. It helps you understand which sound is like musical and tonal, and which one is just noise. Because noise will have all frequencies, and tonal noise, just oscillations of a string, it cannot oscillate in that mode, and so it doesn't have any frequency. Yeah, and it makes sense. Yeah, I think. Like deaf people, for sure, will be easy to discern musical and non-musical sounds. They will say, "Oh, there's music playing," just by looking at this. Yeah, lines. Oh, lines. Where's the music? Where's the sound? And they can maybe go and find it with this. Yeah, and just because it just keeps breaking, I will just make you just demonstrate it a little bit. So bass and hi-hat there. You can guess what happens when you put some clap or snare. I can go.
Feeling the clap. Yeah. So that's like complete the whole spectrum.
Yeah. Again, I don't know. It's some kind of noise suppression. Yeah. So. So yeah, you can see this. You can understand more about high, mid, and low frequencies, and maybe even balance them out because you can see the volume by the brightness of pixels. So maybe I can add some volume to hi-hat. It's getting brighter. And okay, let's go for bass. Ah. Yeah, like this. It's kind of low, yeah, and there's a limit to this analysis, so it doesn't show us one line. It shows a little wide and thick line, but yeah, it is the Fourier transform limitations. So this spans half an octave already, but yeah, it's math. And anyway, you can see that there's not only low frequency. There's this like very bright spike, and you can make a guess about how it's synthesized, and yeah, maybe synthesize something like this for you. And let's look at one thing more. It's arpeggio. Of course. Patterns emerge in front of our eyes, yeah, and also with with filter, yeah, and this is like how it's called, northern lights, yeah, and I can increase some smoothness and even maybe make this more frames per samples per frame, and we get this beautiful picture, and it sounds like this. So it really sounds like far distant bright sound. So you can have this relation to far distant, up, and yeah. So I think this one is one of the most important things, because you don't need to do some particular thing about it. You can just do whatever and just have this feedback loop, and it will teach you by itself. You will have this experience, and it will be processed in the back of your brain. You don't need to think about it much. You just need to try to because yeah, there is a way you can plug the audio from your computer back to here with like loopback driver, so you can analyze any sound from YouTube. And so I was going for birds singing, dogs barking, and different things to look at them. And also there's this breakout window, so you can just have it here. Yeah, you can just go to other tab, and yeah, and if you have this feedback loop back, so open any any application, so you can go with Ableton going through this anything. So very useful. And if you find any flaws or ideas how to improve it, I'm very open. I like to polish things now. I want to polish it down so it doesn't have these nasty bugs, and it works every time and works for everyone.
I think just like some adding comment from me. Normally for spectrogram, it's mostly scientific. It's like something that is
Mm-hmm.
But with the combination of the colors,
Yeah.
just give more meaning or like tonality.
Yes.
Normally it's just like loudness. If it's
Loudness.
it's gonna turn like more range. If it's very
Yeah, maybe cut high frequencies, cut low frequencies, just average thing. Yeah.
so, but this is like I think my first time to see like combination of like tonal color
Mm-hmm.
spectroscopy.
Yeah.
Maybe I'm gonna use this to teach my students.
Sure. Yeah. 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 It's built basically for this. So because you need understanding to explain this, but other than that, you have everything. So those who understand can explain to those who not, and this can propagate. That's my hope. How it moves.
I had tried Sonic Visualizer, if I don't correctly, like it's open source
Mm-hmm.
software. It was very complicated, but like today you made it like very clear. So like I had no clue. I had tried using it. I had
Mm.
used it, but now as you mentioned, it makes much more sense.
Yeah, yeah, yeah. It does. Yeah, because actually, just going to the main page, you can enable this microphone, and it's already showing the same data. So it's and it's guessing the note, and it's also analyzing things. And we've made an art installations, a couple of exhibitions with this system going. Showing the colors and mixing them, and it was beautiful because with it was chroma, the C chroma. So basically, it's the same data but in a different shape. So it shows all the content, and it's kind of random because I'm speaking, but so it's not only showing one note, it's showing all the overtones and the timbre. So you can also, and then you can just drag it and make it blurry, and yeah, put it on a projector in a dark room, and put a mic, and people have fun with it. And it was installed in an installation for a month, and I don't know, thousands of people enjoyed it. It was like a chamber room with great acoustics, and like kind of beautiful. At least I hope so. And educational, so that's why I didn't remove the letters, because let it be educational. And yeah, one thing to show here on this main page is that, of course, we have a keyboard enabled, so you can play your keyboard keys on computer or MIDI keyboard, and it will make sounds. But also, it will show you the chords. It will guess the chord from MIDI. Yeah, yeah. So we have a shape of chords, right? And like, okay, basic triad, yeah. And it's you can even see the difference with major and minor chords, yeah. And for example, C major 7 or C major 8 9, and yeah, it's very interesting to watch and explore. And of course, you can run your sequencer, for example, into it, and you will see what's happening there. Have this feedback, and yeah, MIDI analysis is a whole story. And yeah, I will show you a couple of things. But the simplest thing is that if I have MIDI monitor, so it's showing all the signals from MIDI that are coming from my synthesizer, and I can even send back those signals. And for example, I play this bass, and it's D on 5th channel, and I can play D on 5th channel. And even if I move a slider of filter, then I can move it from here. No, it's not moving. I disabled it right now. But yeah, I mean all this information. So if I play something like moment, I need to find, maybe I have some pattern. Yeah. Okay. Clear it, please. It's sped up, it's just one pattern, but I mean, you can see all the MIDI bus and what's all the events happening there, and yeah, it's a powerful thing to debug things and yeah, to explore. Even easier with this MIDI log that just logs out all the MIDI notes, just note off or CC messages, and yeah, just look at this. But then, you know, I'm an engineer, designer, but also an artist, and yeah, then I go for MIDI radar. That sounds kind of scientific. I will lower the tempo. But I have a fresh empty pattern, so I can show you easy. So this is bass. Okay, let's. And we can send MIDI from here. Clock out, stop, again. Now it is on the grid. So website is sending MIDI via USB, and yeah, it can go further. Yeah, you can adjust tempo here. And it's showing the note of the tempo, so yeah, it's easy. You can just drag around or use this division things, or go with plus and minus. You can tap tempo, so I tap and find any tempo. If I like it, I press this number and it goes to the main. Or this thing can guess tempo from audio. If you have music playing, you press it, it records and it guesses the tempo of incoming sound. And it's sometimes off by 2 BPM. I don't know, but anyway, so this is this MIDI thing, and still kind of stable, and I tried to make the shape meaningful in a way that, okay, this is kind of low thing in the low center, but if we go to any hi-hat, it will be high above, and let's go with yes, it's already MIDI. Yeah, I think eventually I will make this radar for pitch also. It can draw this spectrogram in a circle. It's just math that I need to wrap around my head, you know. But anyway, so this is this. So here is this, and these lines are just snare drums. Let's make one here. Oh, like this, yeah. And then, okay, let's go some bass. Makes sense, right? You can drag around this image and it will change the number of divisions. It will clear out eventually, so you can make longer cycle and analyze maybe, or create more longer pictures. And let's keep it simple. So there's the rhythm of bass, not rhythm, the shape of this bass, right? You can say, okay, this is the shape of this bass. Okay. So all the patterns emerge, and yeah, you can just think about it. Okay. like this. It's small improvisation. Yeah, but I mean drawing with the MIDI. Yeah, and there are so many things to explore, and we will be just finishing by now with all this exploration. I spend sometimes 5-7 hours per day diving into this, because first I write code, then I try to test it, and then I lose myself playing with all this, and at some point when I understand that debugging sessions become performances, I think even if it's polished, or I would anyway switch to other thing, because I still want to develop this and not to find only one thing. I want to explore all the field, and it was the 2.0 version of Chromatone when I was focused on developing ideas to viable apps, and 3.0 is about moving them towards one more integrated experience, so you can have MIDI and sound analysis and some compositional and things in a more coherent way, because now you have to browse all this, and I'm easy with this because I wrote it, and I understand that most of people get lost. But anyway, you can record MIDI here, and it will be showing you the colors, and you can just you see the bass there. It just all gets recorded. Then you press this, and this still doesn't download, but at least you can download this SVG file. Yeah, a MIDI file. There are some bugs, but SVG file is already useful.
This could be good for like composer.
Yeah.
Composer that they do like a graphics board or the program.
Mm-hmm.
Like we can suggest the shape of the control of the notes.
Yeah.
Yeah. So maybe the performer can read it in terms of like not the exact,
Mm-hmm.
but like how to play it.
Yeah, just shape, yes. And my approach is more focused on live music and jams rather than recorded music. I don't personally have any interest in transcribing Bach and Beethoven in color, because I don't really care about past music. I listen to music that's at least 3-4 years old. I think other music, why you listen to this old music? Listen to modern, because it's speaking actual thing, and it's actual thing. But all this, it's my personal thing. I try to not put it much to Chromatone, so it can be universal. But you can see that there are so many live apps and not so many like transcribing and meticulous this like written music apps. But anyway, there are some interesting results, and I will show you one last thing about this practice, because previous app that I was developing is about written music, and it's about jazz standards. So this is the real book, if you know what it is. Yeah, so it's digital real book. Yeah, there's plenty of songs. You can just choose any of them, and it just shows you the chord progression in there. And it's still barely started, because of course I need to play it somehow automatically. Also, of course, I will add transposition, so you can transpose it. But yeah, it's outputting to channel 1, but yeah, let's do it properly. It can go to channel 8, and it will be jazzy. And it's jazz, it's just real book. Yeah, and imagine how many chords, how many songs. It's only C, it's just crazy amount of knowledge that's packed here. And it's just, yeah, it's F, and I don't know how long to scroll it, and it's still working. No bugs there, but pretty simple. And it's my move towards this recorded music and analyzing the more complex composition and harmony, because it's very complex topic. Even I've done research on tritone substitutions and all these jazz moves, but oh god, they are so good at this, so we can learn. But yeah, even for this you can use Chromatone. Maybe it's not easy to use on phone by now, but maybe I will find ways. Because if you press this, it will show you how to play this particular chord. So maybe you won't.
On that is like on the ukulele.
Hmm?
On the right side is ukulele.
Ukulele, yeah, but it can be guitar. Yeah, it doesn't show you particular shapes of chords. It shows you all the possible places where you can put your fingers, and I find it more useful because it's not only one shape and run around one chord. Yeah, but if you need tabs, you have tabs here, so it's just proper database of that's from the DB folder. So you can choose, for example, E major, and this list on left is just mathematically finding all the chords that fit, and then you can just press it, and then you can see that okay, F sus4, you can play 4 shapes on ukulele and 4 shapes on guitar. Yeah, with fingers. So these are fingers, not the note numbers. So what fingers where to press and barre and everything. So I use it a lot. I have a ukulele with stickers, and yeah, it's so nice to explore. I think it will be it for. I will just show you some funny bits that I find. One of these is just Noise Lab. That's about noise, and it's about like you can turn it on and play around this. But it was more fun for me. But yeah, you can make. That's where pink noise and big crusher, and then the crackling. You can go for there. And in synthesis there are multiple synthesizers. One of this is my best by now, but sometimes it's not working because it's kind of heavy already. But yeah, so it's polyphonic. These are voices that get cycled. So 12, but you can just crank it up easily. It's software. So, but the fun thing is that every voice has separate analysis, so you can see the wave shape of each note, and then you can kind of see how they interact. Like this octave, they look close, and these are dissonant, and this is consonant, and yeah, it's analysis. And also there is this oscillator, noise, string, that's Karplus strong, there is sample, all you can turn on and off. Yeah, and some ping pong delay. I had reverb, but it gets laggy because it's heavy calculation. Yeah, I removed it for people not be so frustrated about it. But anyway, so sound font, this is just samples. Very easy to grasp.
Like, because we see a lot of instruments here, how you like cram everything into the web page.
Yeah, it's how it's done. Yeah, it was hard to build at first place when it was like a monolith application. Now it's still a monolith application, but every experiment is a client component. So it's a separate kind of app that's loaded only when you open this page. So it's loading bits and bytes as you use them, because if you will start loading the whole real book when you open the page, it's a big mess. And I had this problem when I was using this complex synthesizer on every page, so you can practice while you read something, and it made the site slower and laggy, and I'm just now resorting to simple samples there. But yeah, it was a big path, big way until I have this. Because I started with WordPress and it was PHP and it was didn't make any sense. JavaScript all mixed together. Now it's all JavaScript from the beginning to the end. But yeah, the best thing is that it's like open source and it renders to a static website. So there's no server behind it. You can just have it locally on your computer, running like I run it, and just build it. It builds in around 60 seconds on my machine, but yeah, it depends on the machine.
So now what we are seeing here is offline.
It's not offline because it's Chromatone.center, but if I press this serve button, it will open in this port.
You can like build like the offline version and then
Sure. You can, and there's 2 steps to make it a desktop application. I just need to go through them. And only problem is MIDI support in this like application. I still didn't figure it out. But even without MIDI, it can take the audio and yeah, you can play with it. But this is totally port 3200 and it's built and it's completely static. So yeah, you can go offline with it. And you can fork the repo. So it's anyone can have it on a computer without internet. After apocalypse, after the global nuke thing, I don't know, we will still have it somewhere on hard drive or in Microsoft Vault that they put all these GitHub repos, because I have this in GitHub. There is the one. I don't remember, where they put it. Probably it's on my page. Where is it? Come on, my page. So I have this. Arctic Code Vault contributor. So part of my code, not the new one because it happened long ago, but some ideas that are there are buried deep in Arctic, so if anyone, in case, they will find it still. And while we're here, I will just show you my graphs. So around 10,000 contributions, like days spent on this. Its longer streak was in 2022, 39 days consecutive work of this. But this is my development graph. So I work on it pretty consistently, and you can see that 23, almost, because in Thailand I have time, I'm very focused on this and not so many distractions. 22 was harder, you see here. But let's go. Just look at this. I'm kind of curious too. So 21, less things happening, but it's growing. So probably from 21, it's just consistent work. But before it was more ideas, but it all started around here. So 2017, I think there are first contributions. Chromatone apps. So it started. Right there. But it's the long way, and you can see that it's not the only app that I have. So Chromatone Center is this main thing. There are my slides. This shop is another open source project. Tutorship Academy, that's all open source too. This is a particular one synthesizer that I made for Playtronica company. They used it for. Really? So it has arpeggiator inside, so you can play random notes, but it sounds good. I'm just doing like this. I'm not playing. And it was important to me to make this pleasant, And there are different scenes here. Where's the sound? It's too low. But it's because their controller is monophonic and plays only one note. It makes sense for them. But this is statistics of notes. So the more you play, the more time you play, the bigger the circle. The more times you play, the longer is the arm. So it's just statistics of your jam kind of thing. And it was creative project. I just will show you one last thing that we built also together with Playtronica is this web synths. It's a great collection of online synthesizers and sequencers and all things. So yeah, it's a huge fresh collection, and there is also my things there. So elementary synth, we tried it, or this touch me is here, and sound font. But
I think we played that before.
yeah, great.
With my friend, like he have like the hardware.
Mm.
We played.
Yeah, because it's just collection. I mean, but I like that it's convenient because you open it all the apps in iframe, so you still have this description of what's happening, and you can put a favorite on it and browse it as a consistent experience for. Like you feel all these synthesizers in one pocket, kind of in one web app, but it's really outside, so it's people build it. I just put it here, and some of them restrict iframe, so I open it in new window. Yeah. So so we will just look at this. So we've looked at theory. We tried some practice. If you have a question in meaningful way, we can discuss it further after, of course, but in a tutorship session, if you would like to go deeper, there's a shop for the stickers, and I will send it across Thailand and globally. Academy will have all the events, and you can look for this. And this support, I mean, it's not only about, it's not that version, yeah. So it's not only about, it's you can share and follow on Instagram and Reddit and share some ideas. You can contribute code and go get involved in open source. You can just put a star on the repo. And of course, I tried to collect donations for this, but Stripe doesn't like donations from other countries if you're in Thailand. It's like the Thailand law that forbids, and so I removed all the donation part from the website and tried to sell stickers. Yeah, but they're kind of expensive, but maybe I will find a way to fund all this, because of course it's not my full-time project, because I don't make much money with this. It's more like art and exploration and my gift to society, but I still believe that it can make me sustainable here in Thailand as maybe a teacher, maybe a tutor, maybe all of this combined. And my biggest plan is to make like a music school club, something like this, because you need time to get well into this, and different people have different needs with education and practice, and we can grow together as community, and across Thailand, I believe, because in Bangkok we have many friends already and many projects, and it's good tradition to come here from Phuket from time to time and have performances and workshops and maybe even more. I will end now without any last thing, because there are a bunch of them. But anyway, if you like, you can contact me. All this this is like all the Chromatone as an organization and me as its author. You can perceive it in two ways. So I'm glad to be here to share all this with you. We will have more casual talks now, but I will finish my workshop. Thanks.
So in the meantime, if you have any further questions, please feel free to ask. In the evening, we'll start from 7. We have I'm gonna play. This gonna play as well, and we have 3 more performers. One of them is like professor at University. Another one is like duo that they develop like the web app that do like drum machines and stuff. So I think
That's
be
really
quite fun. Okay, thank you so much.
Thank you.
Thank you.
Thanks for your attention.